In this segment, we'll look at the UML for the composite design, and we'll introduce the UML notation for multiplicity of reference as well. And we'll talk about several important conceptual aspects of UML class diagrams, and then we'll introduce a sometimes useful UML diagram method for objects as opposed to classes. Now, let's see how our example composite pattern looks then in UML. As you can see in the notes here, the UML class diagram shows component as a base interface with two subclasses, part and assembly. No surprise there. The more interesting thing is the arrow from assembly back to component with the labels 1 and 1 ... star. Let's discuss that arrow for a little bit. Now, as you know from earlier UML discussions, a line between class boxes in a UML diagram indicates a relationship between the classes, and an arrow on the line shows that one class can reach the other, generally via a reference. Now, given the fact that assembly, bring the code back up here for a second, given the fact that assembly includes a list of components, it's pretty clear that an assembly object can reach several component objects via the component references in that list. So the arrow makes sense. Now, in earlier UML diagrams, an arrow indicated that one class had a single reference to the other. But in this case, we have possibly many references from an assembly to different components. The number of possible target objects is termed the multiplicity of the reference, and the 1 and 1 ... star indicate this multiplicity, with a 1 on the assembly end of the arrow and a 1 ... star on the component end, indicating that one assembly object may reach one or more component objects. Question 1, bit of research. What are some other possible options for multiplicity notations in UML? Look them up in your reference chart. And what you should find then, after some work on that, is that the 1 and the star may vary. For instance, the notation 0 and star, 0 ... star, means that 0 or more references might be leading to a component, while 2 ... star would indicate that 2 or more, and 1 ... 3 would mean 1, 2, or 3, and so on. Now, given that the assembly member pieces might be an empty list, the notation 0 ... star might seem more appropriate for our diagram, but UML diagrams generally show the intent of the design, and we don't intend for any assembly to have 0 subcomponents, so we used 1 ... star. Another question here. In this example catalog.txt file from the prior segment, what is the largest number of component objects that any assembly object points to? And note, this is a trick question. So, returning from a pause there, the trick answer is none, of course. Component is just an interface. There are no component objects. That short question was meant to show that the arrow target in a UML diagram can be a bit misleading. The target component is based on the view that the referencing class assembly has of the arrow's target. In essence, the type of reference that assembly uses to reach the target. Assembly uses component references. But assembly actually refers to parts and other assemblies, even though it views them as components. So the UML arrow leads from assembly to component, but don't forget the fact that the actual objects in practice will be parts or assemblies that it's pointing to. Now, as this prior discussion shows, UML class diagrams show how classes relate to one another, but they may miss important points regarding how objects of the classes are actually created and laid out. For instance, given the tree-like composite pattern, one might expect some sort of tree in the UML class diagram, but the tree is made up of objects all of them of type assembly or part. The tree structure is not in the class relationships. It's in the way assembly objects are created and used. An assembly object representing a gadget will point to two other assembly objects representing whatsits, and to a third representing a thingy, and plus several part objects representing a couple of bolts and nuts and a flange. And the whatsit objects will in turn point to a number of part objects, as will the thingy object. Let me scroll it down a little here and see that. It's the specific references in the list component members that form the tree. And putting the same idea slightly differently, the UML class diagram shows the relationship of class declarations. We might get a completely different tree of objects with a different catalog.txt file down here, but the class declarations would be unchanged, and so would the UML class diagram. Now, the lesson to take away from this is that while a UML class diagram may hint at the organization of objects, the assembly to a component arrow at least suggests the possibility of a tree of assemblies, it's not a definitive guide. If you want to specifically show a representative arrangement of objects, you use the UML object diagramming method. And this method, which is what we did here, sees perhaps one use for every 100 uses of a UML class diagram, but in certain cases, such as a composite pattern, it's useful. Now, the notes show an object diagram, as we said for the gadget case just described. The object diagram has rectangles and relationship lines, rather like a UML class diagram, but each rectangle is labeled object name and then class name to clarify that the rectangle represents a specific object. Note, for instance, that several rectangles in the diagram are assemblies and several are parts. Clearly, it's not one rectangle per class, but rather one per object. And the objects are arranged in a tree, showing an example configuration that reflects the design intent. Now, usually you can intuit the intended arrangement of objects from the UML class diagram without any other extra information than that. But when more detail is needed, use a UML object diagram to show representative arrangements of objects.